Hi students, welcome to MC Square for another video class. In this video class, we are going to discuss about section C, model paper 1, that long answer questions which carries 8 marks. So most of them are expected questions are there in this section. But the first question, that is 19th question in section C, 19th question or first question of section C is this. Can you expect this question? What are postulates of Bohr's model of hydrogen atom? Yes, you can expect. You can expect this, right? Most of the times it is repeating. But look at that second part of the question. State HUND'S rule and AUFBAU'S principle. So this is unexpected here. Correct? So with this we expect hydrogen spectrum. But he has given that HUND'S and AUFBAU'S principle. So anyway, even you learn them, you may get. That is why better to learn these also. But Bohr's atomic model is 100%. They will give. But HUND'S rule and AUFBAU'S principles also better to learn. They may give, right? And hope for the best. And with this, you also learn that hydrogen spectrum. So let's go to this answer for this question. Bohr's atomic model, very, very important. There the diagram is there, you can observe. So just we explain about the diagram. Those are the postulates of Bohr's model. Okay. So first question, postulates. Half of the part of the question is what? Postulates. Postulates means important points. Postulates of Bohr's model. Postulates of Bohr's model of atom. Here we are taking a hydrogen atom. Okay. So we know that electrons revolving around the nucleus of an atom in a circular path like this, right? Those are called as orbits or shells. And those shells are designated as or represented as what? K, L, M, N, alphabet or numbers 1, 2, 3, 4. That's our first point. So postulates of Bohr's model of an atom. The first postulate is electrons. You can write whatever we discussed there. Electrons revolve. Electrons revolve around the nucleus. Around the nucleus of an atom. Of an atom. In a circular path. In a circular path. That path is known as, right? Which is known as orbit. Orbit or shell. And designated or represented as alphabet or K, L, M, N and so on, or numbers with numbers 1, 2, 3, 4 and so on. Electrons revolve around the nucleus of an atom in a circular path which is known as orbit. That circular path is known as orbit or shell. And designated as what? Alphabet K, L, M, N or numbers 1, 2, 3, 4. The next point, electrons revolving like this, correct? As long as electron revolving in that circular path, there is no absorption of energy and no emission of energy. Means what? Energy remains constant. Okay, that is why these orbits are also called as stationary orbits or stationary energy levels. Okay, That is the next point. Electrons, energy, right? Energy of electrons. Energy of electrons remains constant. Energy of electrons remains constant when, as long as they revolve in orbits. Therefore, these are also known as what are they known as? Stationary orbits or stationary shells. Stationary orbits or stationary shells, anything you can write, because as long as they revolve in the circular path, there is no emission of energy, no absorption of energy. Means they are not taking energy, they are not giving energy. That is the meaning of that. Okay, but now the next continuation is what? For example, if the electron jumps from higher energy to lower energy, then they will emit energy. Means they will produce energy, they will give energy. Okay, so here that is the next point. When the electron jumps from higher orbit or higher energy level to lower orbit, higher orbit to lower orbit, or higher energy level to lower energy level, energy emission takes place. Energy emission, they will emit energy. Emission takes place. Energy emission takes place. So when we have taken the lower energy level as E1, for example, and higher energy level is E2, then when they jump from E2 minus E1, some energy is emitted. That we have taken that E2 minus E1 is equal to h nu. E2 minus E1 is equal to h nu. What is h here? H is Planck's constant. You know that? Planck's constant. If you remember the value also, you can write. If you don't remember, just write Planck's constant. 6.62 into 10 power minus 27 erg second, or 6.62 into 10 power minus 34 joule second, anything, right? Nu is what? Nu is frequency. E2 is what? Higher orbit energy, energy of higher orbit. E1 is what? Energy of lower orbit. Okay, and when that rotating body is there, all rotating bodies are having angular momentum, correct? Momentum is what? Mass into velocity, right? So that inertia is how many times of velocity, then that is called angular momentum. Okay, so angular momentum of electron, that we are going to write. The angular momentum of electron, is the integral multiples of h by 2 pi. The angular momentum of an electron is the integral multiples of h by 2 pi. That is equal to h by 2 pi. Integral multiples are what? You can take n, right? First, angular momentum mvr is equal to what? Now n h by 2 pi. mvr is equal to nh by 2 pi. What is n here? N may be any integer, 1, 2, 3, 4, and so on. Integral multiples of h by 2 pi. Mass is what? Mass, m is what? M is mass. V is what? V is velocity. Okay, r is what? R is radius of the orbit. H is what? Planck's constant, right? That's about the postulates. These are the postulates we have to write. Then half of the answer is completed. Now we'll go for remaining half of the answer. That is, state HUND'S and AUFBAU'S principle. HUND'S rule and AUFBAU'S principle. Very simple. Means state means you have to just define them. For each definition, we will get 2 marks. So 2 plus 2, 4. And these postulates will get 4 marks. 4 plus 4, 8. That is the separation of marks. So now our next half of the answer is what? HUND'S rule. HUND'S rule. What is HUND'S rule? Pairing of electrons, simply. Pairing of electrons. When we have taken one degenerate orbital like this, degenerate orbital means which are having same energy. Orbitals belongs to the same subshell. For example, this is the p subshell. Electrons fill like this, 1, 2, 3. So all of them will fill with one electron now, right? Then pairing takes place. Then pairing, 1, 2, 3, total 6. So the pairing of electron takes place after all the degenerate orbitals are filled with one electron each. That is called HUND'S rule. For example, you have written like this. This is wrong. Means what? This is violating HUND'S rule. First of all, each orbital should fill with one electron. Then only pairing takes place. But here what? It does not fill with at least one electron, but pairing takes place. It is violating HUND'S rule. HUND'S rule following means what? First, each orbital filled with at least one electron. Okay, then only pairing takes place. So that is called HUND'S rule. So we can write that the pairing of electrons, the pairing of electrons in degenerate, pairing of electrons takes place. Pairing of electrons takes place in degenerate orbitals. Degenerate means which are having same energy, which are belongs to same subshell. Degenerate. The pairing of electrons takes place in degenerate orbitals after filling one electron in each orbital is known as HUND'S rule. Very simple, right? Is known as HUND'S rule. The pairing of electrons takes place in degenerate orbitals after filling one electron in each orbital. That is called HUND'S rule. The next one is AUFBAU principle. AUFBAU principle. Okay. AUFBAU principle is based on electronic configuration. That is, of course, all of them are electronic configuration only. Here, electrons are filled first, which are having least energy. right? So the filling of electrons is based on increasing order of their energy. That is called AUFBAU'S principle, right? So that filling of electrons will takes place. So what we can write this, in the ground state of atom, in the ground state of atom, electrons are filled. In the ground state of an atom, electrons are filled. How they are filling electrons? Electrons are filled in the increasing order of, energy of orbitals. Means what? The orbitals which are having less energy are filled first, then more energy. Increasing order means, right, lower to higher. In the ground state of atom, electrons are filled in the increasing order of energy of orbitals. It is called AUFBAU principle. AUFBAU principle. Okay. So in the ground state of atom, electrons are filled in the increasing order of energy of orbitals, is called AUFBAU principle. So this is the remaining half of the part of this question. Okay. So we'll go for the next 20th question. The 20th question has come from periodic classification of elements. Periodic classification of elements has given classification of elements and periodic properties. So you can guess that question also there also, that they may give that periodic properties, they may give ionization energy and first ionization energy and second ionization energy, and one more question they may give from that chapter is, that is what given here. That question is, write an essay about S, P, D and F blocks. This is the question. Write an essay about S, P, D and F blocks. Right, very simple, right? First of all, we'll take S block elements. S block. Yeah, that structure we will discuss first. S block. Here only two groups are there, right? Yes or no? Only two groups are there. First A and second A. S block. S block. Right? One more we will take D block. This is the D block. And here one more P block. This is D block. Okay. Now P block. P block will be like this. This is P block. P block. And finally, one more block is what? S, P, D and F. Right? Here we will take F block. This is F block. Better to draw this also, that they will understand, we have some idea about that periodic table. Okay. Now we'll discuss one by one all the blocks. The first one is S block. S block means what? S block means here the elements in which differentiating electron means lost electron enter in the S subshell, those elements are known as S block elements. If you understand one, remaining all of them are, of course, almost nearer to each other. So first try to understand S block. So the elements in which differentiating electron enter in S subshell. So whatever the lost electron is coming, that lost electron always enter in the S subshell only. So those elements are known as S block elements. So the elements in which differentiating electron enter in S subshell are called S block elements. Okay. So where that S block in the periodic table, you can say that here it is, right? S block elements, where that left side, correct? Left side. So how many groups it contains means it contains only two groups, first A and second A, right? That we'll write first. This block means S block. This block contains only two groups. That is first A and second A. Groups. Okay. Where they are placed, that also should write. Which placed at the left side, correct? At the left side of the periodic table. Okay, this block contains only two groups, that is first A and second A, which placed at the left side of the periodic table. That is the second point. Now the third point, you should write that, very important point, electronic configuration. The general electronic configuration of S block is what? NS 1, 2, 2. That's it. NS, that S orbital contain either one electron or two electrons. That is why we call them as S block elements. Okay. So the general electronic configuration of S block elements is NS 1, 2, 2. Okay. And finally, the fourth point, you can write that the S block elements are metals, right? All of them are metals. That is why we are calling them as alkali metals and alkaline earth metals respectively, first A and second A. Okay. The S block elements are metals and have more electropositivity or ionization. Yeah, I can write have more ionization enthalpy or ionization energy, ionization enthalpy values. That's it. So the S block elements are metals and have more ionization enthalpy values. That's about S block. Only 4 points. Okay. First, in the first point, we will write definition. In the second point, we will write where they are present and what are the groups they are having. Third point, we will write general electronic configuration. Fourth point, extra about that properties of S block elements. Okay, so we'll try to write remaining P, D and F blocks also in the same way. First definition, then where they are placed and what are the groups it contains. Third point is general electronic configuration, and fourth point is the property of them. Any one property of them you can write. Okay, so then directly I am writing that P block. Just try to understand. No need to write again. Those are very simple. P block elements. The elements in which S block means I'm reading S block. The elements in which differentiating electron enter into S subshell are called S block elements. P block means what? P subshell. Very simple, right? The change is only this. P subshell are called P block elements. The elements in which differentiating electron enter in P subshell are called P block elements. Okay. This block contains how many groups here in the P block? Third A, fourth A, fifth A, sixth A, seventh A, eighth A. Total how many? 6 groups. Okay. So here this block contains how many groups? That is, you should write this block contains 6 groups. Okay, 6 groups. What are those? Third A, fourth A, third A, fourth A, fifth A, sixth A, seventh A, and eighth A or 0. Anything you can write. Eighth A groups. Second point also completed. And which placed at where they are P block, which side? S block is at left side, and these are at right side. In the place of left, you should write right. Okay, right side of the periodic table. Very simple, right? If you know one block, remaining all blocks you can explain. The general electronic configuration is here NS2, NS2, and NP 1 to 6. This is the general electronic configuration. NS2, NP 1 to 6 is the general electronic configuration of P block elements. P block elements. And finally, the P block elements are metals he wrote here. The P block elements are metals, non-metals, and metalloids. Okay, all of them they are contain metalloids. They may contain metals, they may contain non-metals, they may contain metalloids also. Okay, this is the fourth point. Okay, and we may add one more thing here. And S and P block elements, S and P block elements, S and P block elements, except 0 group, are called representative elements, representative elements. Okay, this is the fourth point. Even you may stop here. Here also nothing will happen. You will get the marks. The P block elements are metals, non-metals, and metalloids also. So that's about P block elements completed. Okay. Now next one is what? D block elements. Right. Third one, D block. The elements in which differentiating electron enter in which subshell now? D subshell. But you should write that somewhat an extra word you should write, that penultimate enter penultimate n-1 D subshell, n-1 D subshell. Penultimate, those are called D block elements. Penultimate means what? After ultimate. The topper is ultimate student. The second topper is penultimate. Okay. So here n is ultimate. N minus 1 means one rank is less, n minus 1. Okay, that is called penultimate. Penultimate n minus 1 d subshell are called d block elements. Okay, the elements in which differentiating electron enter in penultimate n minus 1 d subshell called d block elements. This block contains how many groups now here? D block is containing 3rd B, 4th B, 5th B, 6th B, 7th B, 8th B, 1st B, 2nd B. All of them how many? 8 groups. Okay, this block contains 8 groups. That is, what are those you should write? B, 3rd B, 4th B, 5th B, 6th B, 7th B, 8th B, and what? 1st B, and 2nd B groups. Total how many? 8 groups are there. 1st B and 2nd B. Which placed at? Where they are placing? Left side or right side? Not left side, not right side also. They are placed in between, middle portion you can say, right? Middle portion of the periodic table. Which placed at the middle portion. Which placed at the middle portion of the periodic table. That is the second point. The next point is the general electronic configuration is for d block elements. This is very, very important point. Definitely should write this. Otherwise, you won't get marks. N minus 1 D 1 to 10 and NS 0 or 1. N minus 1 D 1 to 10, NS 0 or 1. Okay. Next one, 4th point, the P block elements are metals. So you write here, the D block elements are metals. Metals, also known as metals, also known as transition elements. Transition elements. Okay, transition elements. One more point you can include here. Transition elements which contain variable oxidation numbers. Variable oxidation numbers. Okay. The D block elements are metals, also known as transition elements, which contain variable oxidation numbers. That's about D block. So same points again, definition, and what are the groups, how many number of groups, and what are those groups and where they are placed. And third, general electronic configuration here. Sorry, this one is N minus 1 D 1 to 10, NS 1 or 2, not 0 or 1. And the D block elements are metals, also known as transition elements, or transition metals also, which contain variable oxidation numbers. Means they possess different types of oxidation numbers. Either S block and P block and F block, which don't possess. That is a special property of D block elements. Okay. And finally, F block elements. F block. So the first one is definition as it is. The elements in which differentiating electron enter. Here again change. What is that? First one means ultimate. Second one means penultimate. Third again before that. That is called anti-penultimate. You should write that anti-penultimate. Ultimate, penultimate, anti-penultimate. Ultimate means N, NS or NP. Penultimate means N minus 1 D. Anti-penultimate means N minus 2 F. So those are known as F block elements. First point is completed. This block contains, there are no groups actually. We can't say that groups. This block contains two series. Okay. That horizontal series, two series are there, that you should write. This block contains two series which named as lanthanides, correct? Lanthanides and actinoids. Lanthanides and actinoids. Okay, which placed at where they are placing a block. You can observe in the diagram where we are placing bottom portion of the periodic table. Second point also complete. Third point is what? The general electronic configuration is. Here now we have to take that general electronic configuration. Now the last electron, differentiating electron, where that is entering. The differentiating electron entering where? In the f orbital, n-2f. Okay, so you can say that n-2f 1 to 14, n-1d 0 or 1 and ns2. This is the general electronic configuration of f block elements. Okay, and the f block elements are metals, and most of them are radioactive elements, man-made elements and radioactive elements. Metals and radioactive elements. Okay, that's about F block. So if you understand what is S block and what are the points we are writing in S block, remaining all the three are, you can write with slight difference. Okay, the main difference is general electronic configuration and place where they are having differentiating electron, penultimate and anti-penultimate, number of groups and what are those groups. Okay, and the last fourth point you should write that any one of the property of S block, P block, D block and F block. Not only this, you can write anything if you know that. Okay, so that's about that general electronic configuration, very, very important. Without writing that, you can't get marks. Okay, this is about F block elements and essay about S, P, D and F block. Okay, and the last question in this question paper, that is 21st question. We will go with that. So here in the first year we have that 8 marks questions. They may come from first chapter or second chapter or third chapter or last chapter, organic chemistry. But we have seen that in organic chemistry already we got 4 marks. In the form of 4 marks we got 2 questions we discussed in that 4 marks video. Now the remaining only one chapter is what? That is chemical bonding, right? So the last question has come from chemical bonding. Is asking that explain the hybridization involved in SF6. We can guess this question. Either PCl5 or SF6, both of them are very, very important. They may come for 4 marks also. If you learn this, you may get 4 marks also. One more important question also, what? FAJANS rules. Okay, this is also important. So we'll discuss that. First, A. We are going to discuss about the hybridization, right? Hybridization involved in SF6. That we will discuss first. Hybridization involved in SF6 molecule. So we know that according to Westport theory, if 2 bonds are there, 2 sigma bonds are there, then that undergoes sp hybridization. 3 are there, sp2, 4 are there, sp3, 5 are there, sp3d, 6 are there means sp3d2. Okay, and structures also should remember, sp is linear, sp2 is trigonal planar, sp3 is tetrahedral, sp3d is trigonal bipyramidal, sp3d2 is octahedral. So based on the electronic configuration only, we can find out this. The central atom, first point we are writing that the central atom of SF6 molecule, the central atom of SF6 molecule is sulfur. Okay. So, and the electronic configuration of sulfur, what is the atomic number? 16. So what is the electronic configuration? 1s2, 2s2, 2p6 and 3s2, 3p4. Why I am writing that in different color means that is the outermost electronic configuration, 3s2, 3p4. That is important here. 3s2, 3p4. 1s2, 2s2, 2p6, 3s2, 3p4. So this is the ground state configuration. You can take that electronic configuration as second point. Sulfur Z is equal to 16. Ground state configuration. So what will come here? 3s2, 3p4. 3s2, S is containing only one. P orbital is containing 3 subshells. Okay, 3s2, 3p4. So what will come here? 3s2 means 2 electrons. 1, 2, 3, 4. Which rule this one? How I filled 1, 2, 3, 4 pairing? That is HUND'S rule, based on HUND'S rule. 3s2, 3p4. So, but we have total 6 fluorine atoms. Each fluorine is containing one single electron. So, each fluorine required to make a bond with sulfur, single electron. Total 6 fluorines required how many? 6 electrons. But we have how many electrons here? Only 2. So, this will go to excited state. Sulfur will go to, we are giving some energy and it will go to excited state. If you take first excited state, what will happen? The electron which is present, yeah, here we have to take the D also, but D does not contain any electron, 3D 0. When we are giving energy means this electron will jump here. Okay, in the first excited state, what will happen is electron which is in the p orbital, 3p4. Okay, and here 3d. So electron which is jumping here, 1, 2, 3. Here it is pairing red, that will jump like this. Now how many unpaired electrons we got? 1, 2, 3, 4. But how many fluorines we have? 6. So it will go to another excited state. This is the first excited state and it will go for second excited state. Then what will happen? This electron also will jump to the d orbital. Now 3d0 has become what? 3d2. Correct? 3p4 will become 3p3. 3s2 will become 3s1. Right? So what is the hybridization now based on this? 1s, 3p, 2d, sp3d2 hybridization means sulfur undergoes sp3d2 hybridization. So sp3d2 hybridization means how many orbitals will form? Right? Yes, 1s orbital, 3p orbitals, 2d orbitals. Total 6 are there. 6 sp3d2 hybrid orbitals it will form. Okay. So the next point, sulfur. So that central atom is sulfur only. Sulfur undergoes sp3d2 hybridization. Okay. And form how many hybrid orbitals? Sulfur contains 6 sp3d2 hybrid orbitals. Which overlap with p orbitals of 6 fluorine atoms. Okay. In which manner? The shape we have to write in octahedral manner. So here the hybridization is sp3d2 and the shape is what? Octahedral. So the fourth point we have to write the shape. We have to draw that, right? Sulfur, fluorine, right? Octahedral means you know that all the fluorines, 4 fluorines out of the 6 fluorines, 4 fluorines are present on the plane and remaining 2, one is above the plane, another one is below the plane. So here this F will be here and this F will be here. Okay, this is called octahedral manner. In octahedral manner, this is there. Okay, bond angle is how much here? 90 degrees. Bond angle is 90 degrees. What is the shape? Shape is octahedral. What is the hybridization? sp3d2 hybridization. So 4 points, 4 marks. Even 1 point you missed means you won't get marks. Okay. In the first point, you should write general electronic configuration. In the second point, you should write orbital diagram. In the third point, you have to explain how many hybrid orbitals are overlapping with what. And fourth point, you have to draw the structure. Then you will get 4 marks. Okay. That's about half of the question of 21st question. Now we'll go for the remaining half. Remaining half of the question is remaining half of the question also will come from same chapter, right? Chemical bonding. As I told, that is the FAJANS rules. Explain the FAJANS rules with examples. That is the question. Okay. Explain the FAJANS rules with examples. B. FAJANS rules. Most of the times he has given this in the model paper, and you can say that very few times we got this in the board exam. Anyway, whatever we have to discuss, that they may ask that, better to discuss this also. FAJANS rules are for to tell the nature of bonds. Either the bond is a covalent bond or ionic bond. Okay, what are the rules for that? If it is covalent bond means what is the rule? If it is ionic bond, what is the rule? Okay, the 4 rules are there. That 4 rules we will discuss. The first rule is as the size of anion increases, the covalent nature of bond also increases. This is the first rule. Means what? Size of anion is more, then covalent nature also more. Okay, as the size of anion increases, the covalent character or covalent nature of bond also increases. Example you can take, right? You take lithium chloride, lithium bromide, lithium iodide. So all the 3 examples are containing same cation, but anion is different. Chlorine, bromine, iodine. Chlorine, bromine, iodine, all of them are present in the 7th group elements, that is halogens, right? So top to bottom, the atomic size, what will happen? Increases. Chlorine to bromine, bromine to iodine. Now you can say that which anion is having more size? Iodine. So that is why this is having more covalent character when compared with lithium bromide and lithium chloride. Correct? This is the order, covalent order. This is what? Less covalent character, less covalent. This one, more covalent nature. more covalent. Why? Reason is what? Iodine is having more size. Anion size is more there. That is why more covalent. Second rule, opposite to this. Second rule is exactly opposite to this. As the size of cation, in the place of anion, you write cation. Remaining same. Don't write again increases. Okay. As the size of cation you have to write increases. Don't change that as decreases. Cation increases. Then the covalent nature of bond also increases. You observe that where we have changed covalent nature increasing and size of cation increases. Just we have changed cation instead of anion. Okay. Cation instead of anions. Cation decreases. Oh, sorry for that again. Cation decreases. Okay, cation decreases. As the size of cation decreases, the covalent nature of bond also increases. Okay, also will not come here, right? As the size of cation decreases, the covalent nature of bond increases. So if you take different types of cations here, lithium fluoride and sodium fluoride, potassium fluoride. So here anion is same, lithium fluoride, sodium fluoride, potassium fluoride. Anion is same, cation is different. So lithium, sodium, potassium, again all of them present in the group. Top to bottom size increases. Lithium is having less size. Cation decreases, size of cation decreases, covalent bond increases. So here what? Lithium fluoride is more covalent, right? Greater than. And potassium fluoride is what? Less covalent. Okay. As the size of anion increases, covalent nature increases. As the size of cation decreases, covalent nature increases. So less cation size, more covalent. More anion size, more covalent. Okay. Next, the third rule. If the charge of cation, or anion or both, if the charge of cation or anion or both increases, then the covalent nature also increases. Covalent nature also increases. Okay, where the charge is more, there the covalent nature is more. That is the point here. Charge is more means covalent nature also more increases. If you take here, you take that stannous chloride, SnCl2, SnCl4. What is the oxidation number for this? Charge is what here? Charge is here +2, because 2 chlorines are there. This is +2. Here 4 chlorines are there, +4. Which is more covalent? SnCl4 is more covalent. According to that point, charge is more, then covalent character is more. So SnCl4 is more covalent in nature, and SnCl2 is less covalent in nature. Less covalent. More covalent, less covalent. Okay. Now the last point, fourth point, cations with pseudo gas configuration. You have listened that noble gas configuration, right? Now pseudo noble gas configuration. In the outermost shell, 8 electrons are there, means there is noble gas configuration. If 18 electrons are there, that is called pseudo noble gas configuration. Now the point is, the cation which is having pseudo noble gas configuration is more covalent when compared with normal noble gas configuration. So the fourth point you can write that the cation with pseudo noble gas configuration, as I said, that cation is containing 18 electrons, noble gas configuration, 18 electrons in the outermost shell, is more covalent. The cation with pseudo noble gas configuration is more covalent than the cation with noble gas configuration. Okay, the best example for this is cuprous chloride, CuCl, right? If you want, you can write that also. CuCl means Cu plus. Cu plus is containing pseudo noble gas configuration, means the outermost shell of copper is containing 18 electrons. 18 electron means pseudo configuration. So pseudo electronic configuration means that is more covalent, means here CuCl is more covalent. So CuCl is more covalent because that is having pseudo noble gas configuration. NaCl is less covalent. Why? Because Na plus cation is having noble gas configuration only, not pseudo noble gas configuration. Okay, so very simple. Which are having more anionic size, more covalent. Which are having less cationic size, more covalent. Which are having more charge, more covalent. Which are having pseudo noble gas configuration, more covalent. So this point you should remember. More ionic size, right? Less cationic size, more charge of cation or anion or both, and the last pseudo noble gas configuration. All these four represents more covalent nature of bonds between those molecules, right? So that's about FAJANS rules. The last half of the part of the question, FAJANS rules also completed. So that's about 8 marks questions in the model paper. You can watch 2 and 4 marks also in other videos of our channel. Thank you all. See you in the next video. Bye bye.